Okay, today we're going to do two things. Learn to identify outliers. There's a formula for that. And then make and interpret box plots. Kind of fun, really fun to do on your calculator. Okay, the most common method for identifying outliers is based on a resistant measure of variability, the interquartile range. So we like to use IQR to use this. So this is the formula. I call it the upper fence and the lower fence. So it's just kind of a mark like if a value is smaller than the lower fence, it's an outlier. If a value is bigger than the upper fence, it's an outlier. So it's just Q3 plus 1.5 IQRs or Q1 minus 1.5 IQRs is the lower fence. So you might on the AP, that's the 1.5 IQR rule. If they say the 2 IQR rule, it'd just be the same thing but multiplied by 2. So same formula basically. Occasionally you see that they'll ask you about something, but this is the most common for sure. Catamarans, I think we mentioned this. Here are the freshwater capabilities. This is a problem we did a little while ago. Okay, so use the 1.5 IQR rule to identify any outliers. So let's see, I don't think I typed this data in, so I'm going to go ahead and type this data in. So we have it. Call it cata or catamaran, 155. Oops, 0.5. Okay, so we want to identify, do one variable stat. So we go to add a calculator page, control doc, menu 611, choose cata, do my stuff. So it gives you the mean, the standard deviation, the median, but we need Q3 minus Q1. So 206 minus Q1 is 145. So we know the IQR is 61. So the lower fence is going to be our Q1 minus 1.5 times the IQR 61. The upper fence is going to be Q3, which I think is 206, plus 1.5 times 61, which is our IQR. So I think those are lower and upper fences. If we have any values smaller than 53.5, we don't. That would be an outlier. Or anything bigger than 297.5. Let's see. 360 is definitely an outlier, right? So it's bigger than our upper fence. So they did it the old-fashioned way, put them in order, found the median, then left all those numbers to the right and left of the median, and they found the IQR, and they found the upper and lower fence. There are no low outliers. There is one that is an upper outlier because it's bigger than 297.5. It's 360, so it's a high outlier. There are other methods. Any value that is more than 2 standard deviations from the mean, again, same formula, you just plug in 2 there instead of 1. That's interesting. Oh, they're just saying the mean times 2 standard deviations. If you go 2 standard deviations below the mean and 2 standard deviations above the mean, I think, is what that's saying. It's kind of written weird there. Unless otherwise indicated, we always use the 1.5. That's really the one we usually use. They'll give you the formula. They'll write it better than they wrote it. They did not write that very well. The mean and standard deviation are not resistant, right? Important to identify outliers. Why do we identify outliers? Actually, there's some pretty good reasons for that. They might be inaccurate data values. Sometimes an outlier is just a mistake. Like they just wrote down one extra digit or one less digit or something, and that could be a way of finding possible mistakes. They can occur, indicate like a really exceptional basketball player, whatever it is you're studying, but wow, this person or this thing did really good. They can also heavily influence the values, so they're worth studying because they're having a huge effect on all those non-resistant measures: the mean, the range, and standard deviation. So another way to display quantitative data is a box plot. I love a box plot. It's very nice. It's not great for shape, but it's really nice for some other things. You're going to use the 5-number summary, again, to show you that 5-number summary with the data we have. So you can see right there, you have the minimum, Q1, median, Q3, and the max. So that's the 5-number summary. We would use that to create the box plot with a visual picture of the 5-number summary. Here, the typical depth of the ocean is greater than 2 miles. Is that true? To investigate, 14 randomly chosen locations were selected. Here are their depths in meters. So again, I'm just going to type this into your calculator. So going to list in spreadsheets, depth, I guess. And the first couple there, 5161. Oops. 5161. 747. 58. Such weird numbers here, so it's quite a bit difference. So, 907 5361. Really nervous I didn't type these in right. There's so many crazy ones. There's 14. I got 14 of them. They look about right, I think. Okay. So I'm going to go to got a calculator page and go menu 611, choose depth, and do it. Okay, so that's my 5-number summary if I did it right. If there's 14 terms, there's 2 in the middle. So if they order these and they find the 2 in the middle, it would be the 7th and the 8th term. If you divide 14 by 2, 7, so it's the 7th and 8th. So right in the middle, you kind of draw your line there. That splits the data, so there's 7 on each side. So there is a middle of the bottom 7 and a middle of the top 7 numbers. That's your Q1 and Q3. That's the 5-number summary. Okay, so see if they got the same 5-number summary, because I was a little concerned I didn't type it in right. It does look right. Good, same 5-number summary I got. Okay. So then you can do this IQR 1662. You can figure out your outliers, potentially. And it looks like we do have, for sure, a couple of low outliers. 1006, so 2 numbers are smaller than that. And no high outliers, so just a couple of low outliers there. So when you're graphing this, what you want to start with is equally scale out the scale for depth. Because the biggest number was around 6,000 there, 6,006, 1 to 6,000. Maybe I'd go 1 to 7,000 personally, but something like that looks good. So you can do the Q1 and Q3 and draw your box. That's not a bad way to do it. So remember, Q1 was 3499. Q3 was 5161. So you draw your ends of the rectangle box there, and then just draw your box. The median is you draw a line through where the median is. In this case, the median was 4030, so just a little more than 4,000. The low outliers, you put as separate dots. They are unconnected dots. And one thing you would have to do, so let's see, the 2 outliers one's at 747. If you look at the data, the number after 747 is 1372. So I will need that information, because once I do that, you see this bottom line, this whisker that comes out of Q1 and goes towards the outliers there. It stops at 1371 or whatever that number was that I just saw. So the next biggest number after the outlier would be where that kind of whisker ends there for the box plot. And on the right, there's no dots because there's no outliers on the right. There's only low outliers. Low outliers are unconnected points there. What's the question? It says, does the graph support the claim that the typical depth is greater than 2 miles or 3219? Yeah, 3219. So I would say 75% of the data is bigger than that, right? Because Q1 is there at about 3,500. So you have 75% of the data to the right of that. So over 75% of the data is within that. So definitely more than that. Quick summary based on the center. You can probably tell the shape probably is skewed left here, but it's not a great use for a shape. But center, we know it's skewed, so it's going to be median and IQR here is what we need. They don't give a complete picture of the shape, really. Oh, I didn't show you this. So this is pretty nifty. So on the calculator, if you hit Control Dock and go to Data and Statistics, like we did before, you can choose the depth here, and you get a dot plot. But what's nice is if you go to Menu, I can change the plot type to whatever I want. I want a box plot. Oh my goodness. It draws a box plot. It shows you those are outliers. If you hover over them, it shows you the values. It shows you that value 1372 that I told you would be the next smallest value. That's Q1, median, Q3, and the max. So really nice. They scale it for you. I mean, that's so nice, right? So I like that box plot a lot that the calculator does. It tells you if there's outliers. If you want to know, hey, are there outliers? Just graph it, box plot it in your calculator, and you can tell if there's outliers or not. They use the 1.5 IQR rule that we usually use. Okay, good. That's your lesson for today.